Okay, how do you graph a secant graph? Well, let's start off with some points. Let's just check some points. At secant, when x is 0, y is, we're going to have a value of 1. Okay? Actually, we have 1 over 1 for our secant right here, because it is the reciprocal of the adjacent, which would be 1 over 1. So, and then what happens then at pi over 6? Well, at pi over 6, normally we have a number just a little bigger than 1. And at pi over 4, you get the square root of 2, which is 1.414, which would be right there. And when we actually get to pi over 3, it's actually, I think it has a value actually at 2. That probably should be right at exactly at 2. My graph might be off just a little bit, so I plug these in. But then what's going to happen as we get to pi over 2? It becomes undefined. Well, what happens is we get real close to pi over 2, we're going to have values that make it go up here where we have an asymptote forming right here. Ooh. Okay. Well, wait a minute. So it goes right here and does that. What about if I move past it and this value right here on the negative side, as I move into quadrant 2, remember x is negative, so secant becomes negative. So instead of being real close up here with positive infinity, we flip automatically down to negative infinity. And then at 2 pi over 3, we're actually at negative 2 is the actual value. At 3 pi over 4, we're going to be at negative 1.414 because that's the negative square root of 2. And then we're going to get closer to negative 1 at 5 pi over 6. And actually at pi, we actually hit negative 1. We actually hit negative 1. What would happen if I was to keep going right here? Well, that would be the same thing as being over here in quadrant 3. This is quadrant 1. Here are my quadrant 2 answers. The next thing over would be a quadrant 3 answer, which is the same thing as I'm going to get right here. I'm actually looking at quadrant 4 answers right now. And it messed me up. Notice my value is positive. And in quadrant 4, as I use a negative pi over 4, I have a value a little bigger than 1. Actually, this is not negative pi over, it's negative pi over 6. Negative pi over 4 is actually positive square root of 2, which would be decimal 1.414, about right there. And then as we move to negative pi over 3, that actually should probably be at 2, at positive 2. And then we're going to actually have another asymptote at negative pi over 2. And as you get closer to it on the positive side, we have this right here. Then what do you think is going to happen down here? Just like what happened here, we're moving up positive. Here, secant is positive in quadrant 4, but in quadrant 3, it's negative. And so actually that's negative right there. That point right there would be negative 2 pi over 3, which is negative 2. Negative 3 pi over 4, right there, which is negative 4.14. Then we're going to be getting closer to negative 1. And we actually hit negative 1. And you can see that's what a secant graph looks like. Looks a little bit like the cosecant graph.
Tardy sweep in progress. Tardy sweep in progress.
Oh, you can tell we're at school if you heard that going on. So anyway, right there we go. We have this nice U-shaped parabola right here. And here we have half one. But guess what do you think would happen if we kept going? It would match up with that and make a parabola right there. Now, this is how we graph it by finding a bunch of points. But the easiest way to graph it is really to do the following. Does anybody recognize what that graph is right there? It's a cosine graph. Notice at 0, 1, it's up here. And the easiest way to graph this would be to put some asymptotes. Look at your cosine graph. And anywhere cosine hits 0, put some asymptotes. And then we're going to put dots wherever it hits, its cosine hits a maximum or